No, ha, I forgot one thing. Density diffusion still has to be added. Okay, we have the second derivative terms up here, the x direction and the y direction, and this is a little instruction of how do you define it, and you can, in principle, even have a variable diffusion coefficients. These k values can change and can make it more complex, and you can even use something that we call turbulence closure scheme. Okay, and this little sketch tells you where these diffusivities are calculated and how you can work out the values for these diffusion coefficients. Okay, so they're calculated between adjacent density values. All right, but enough of that, and you can look up the details if you. More important to know is that you're using a density conservation equation that has two effects: advection and diffusion. So advection arises from the dynamics, from the currents that you create, and the diffusion effect is controlled through the setting of these diffusivity. These are parameters on the model, and if you set it to 0, diffusion, or the real physical diffusion effect, disappears. But indeed, even if you use advanced TVD advection schemes, you still have artificial numerical diffusion. So now we look at an example set. Have a look at it.